So let's do a hands-on demo showing the IAR embedded workbench together with Renesas RISC-V board, the FBP-R9. So Renesas provides a nice code generation tool called the Smart Configurator for RISC-V. So let's start that and let it generate the demo code for us. So this is the tool, the Smart Configurator. You can click on New there, and it will open up a dialog like this where you can select the board that we have, the FBP-R9, and you select the tool chain, that's IAR RISC-V tool chain. And I know that this tool can generate a Blinky project, so let's call the project Blinky, and the project will blink an LED on our board. So I will select the bare metal Blinky project here and finish. And now this tool will generate code, but we have the chance to do some configuration first. So let's have a look here. It shows an overview of the MCU like this with all the pins. And you can configure some stuff here. So let's have a look at the board level. It's the board that we selected, FBP-R9. And you can also configure the clock configuration on the CPU like this in a nice graphical view. And as we can see, the CPU frequency is set to 48 megahertz on our device. So it's configurable, but let's stick to the default here. So 48 megahertz. On the system tab, we have the debug interface setting, and by default it's set to CJTAG, and that's those two pins that allows an external debug connection using the CJTAG protocol, so compact JTAG. So if I just try to select unused here, those pins will be available for other functions, but we want to use the CJTAG interface, so let's keep it enabled like this. On the component tab, you can configure BSP settings. So the startup code is enabled here. It's the BSP startup code that we will be using. It's possible to configure things like this user ID setting. As I understand it, it's for authentication, so sort of password to access the device, but default settings are good here. You can do things like enable the data flash memory area. By default, it's disabled, so let's keep it that way. You can configure different settings for the pins and also interrupts. But for our demo here, the most important setting is the CJTAG, that it's enabled. So let's go up here and do generate code. Proceed. Right, so let's have a look here. The code generation is successful and it's placed in this folder, so I can just click that one and it will open up the folder with the generated code. And if I go to workspace, I will find the IAR embedded workbench generated project here, so Blinky. So what I can do from here is simply just drag this one into the embedded workbench that I have opened in the background here. And you will see the generated code is available. We can open up main.c and have a look here. Yeah, as we can see, the project simply toggles an LED status, so it will blink an LED on this board with a 500 millisecond delay. So let's have a look at the project options here in the workspace window. So I can right click options, and as we can see here on the general options, the device is set to R9, so that's our Renesas device. And IAR Embedded Workbench supports a lot of devices, but this is the one that we have chosen, right? So this device supports the multiplication, atomic instructions, compressed instructions, extensions, the standard extensions. There is no floating point FPU unit, and it's an RV32i device. Bit manipulation extension is available, CBA, CBB, and CBS. And yeah, you can select a lot of extensions and options, but since this device don't support every single extension out there, we only show the available ones. You can set things like the stack and heap size on this tab. You can select if you want to use the normal runtime library or no runtime library, or yeah, libc++ for C++17, for example. Let's have a look at the compiler options. The language configured in this project is the C language. Optimizations level is set to low in this project, so that's good for debugging purposes. On the preprocessor tabs, we have the include directories where the header files are located. Yeah, on the debugger side, you will find that the iJet debug probe is pre-selected. We use a flash loader to download code into flash memory. And if we have a closer look at the iJet specific settings, we can see that the reset type is set to software. And the most important thing here is that the interface, the debug interface, is CJTAG. So that was the one that was selected in the Smart Configurator. So that's good. So yeah, one more thing in the project options. We can have a look at the linker configuration file. This is provided by IAR Embedded Workbench. So if I click OK there and simply build the project with project rebuild all. Okay, build succeeded. So we have built our application. You can go back to main here. From here, I will simply press download and debug, and the application will be downloaded into the board, into flash memory using the iJet debug probe. So if I simply just execute this application, I can see that the LED is blinking on my desk here. I will pause execution, and we end up in this delay wait function here. It's an assembler routine actually. So I can go back to main, set a breakpoint, and execute. And okay, execution stops here. So from here I can open, for example, the registers window and have a look at certain CPU registers. Okay, I can also go to the stack window, and if I step over this function, I can see that in total 100 bytes of stack has been used. If I step into the software delay function, and I see here there's a variable eClock rate, I can step over that one, and this window will show what's on the stack. So it also identifies that this is the iClock rate variable. And now there is also a loop count variable on the stack. So that's about it. That is the demo.